Welcome to another math lesson here, grade 10s. Before we get started here, I got another terrible joke to share. The Secret Service has just had to change protocol for when the president is in danger. Instead of yelling, "Get down!" they have to yell, "Donald, duck!" Alright, and with that poor attempt at comedy, here we are again for another factoring lesson. So, we started off this chapter first actually doing expanding using FOIL and that chart method. Then we got into our factoring method. So our first one is common factoring. We always want to try this one first. If we aren't able to do any common factoring, then we got to look and see if we have one of these two situations. So our previous lesson we covered difference of squares. This one we're going to be looking at sum and product. So in just the name itself, sum basically means adding, product means multiplication. So in this method of factoring, we're going to need our numbers to add to a certain number and also to multiply to a certain number. So let's take a look at our first one. So in our first one it says x squared plus 7x plus 12. This is going to be something that we're going to be able to use our sum and product factoring method because first off, there's nothing we can take out of all three terms. So common factoring doesn't apply. Difference of squares, there can only be two terms, so it can't be this one, which leaves us with our third option here. So in sum and product, we need to add to our variable term here that's in the middle, and we have to multiply to our last number here. So now we've got to come up with some numbers. What multiplies to 12? But also adds to 7. So the best way to do this is to focus in on the multiplication part first. So if I look at 12, and I break this down into its factors, how can we get 12 as a product? We could do 1 times 12, we could do 2 times 6, we could do 3 times 4, and those are all of our ways of getting 12. Now, do any of these choices here also add to 7? And that's where we see 3 plus 4 is 7, 3 times 4 is 12. These are going to be the two numbers we need. So we take those two numbers, and the order doesn't matter. You can do it 4 plus 3, 4 times 3. And we're going to use those to factor our trinomial here. So this has 3 terms. And this is going to look kind of similar to difference of squares. We're going to have 2 sets of brackets. But now we're going to have an x plus 3 and x plus 4. So the two numbers we came up with that satisfied our sum and our product get placed at the end here with some x's at the beginning. Okay, let's take a look at this one here. X squared minus 2x minus 15. Okay, so I'm gonna, I'll erase this later, but if we look at two numbers that add to negative 2 and multiply to negative 15. Okay, we always have to start with that product. So what multiplies to negative 15? We could have 1 times negative 15. You could have negative 1 times positive 15. 2 doesn't work. We could have 3 times negative 5. We could have negative 3 times 5. And that's it. So one of these 4 have to be our best option here. Now, 1, negative 15, do those add to negative 2? Nope, can't be that one. Negative 1 plus 15, nope, can't be that one. 3 minus 5, hey, that works. So if I had 3 plus a negative 5, I get negative 2. 3 times negative 5 gives us 15. And I didn't really give myself a whole lot of room here, so I'm going to change color here. Okay, we put our x's up the front, and then our two numbers. So we have a positive 3 and a minus 5. So that is now factored using our sum and product. Okay, and just like before when we were looking at difference of squares, if you multiply these back out using our FOIL method that we learned at the start of the chapter, we should be able to get back to the original expression here. Okay, so I'm going to just erase that here for now and move on. So now I've got a little bit more space here. We need to find two numbers that add to 3 and multiply to negative 18. Okay, negative 18. We could have negative 1 times 18. We could have 1 times negative 18. We could have 2 times negative 9. We could have negative 2 times 9. We could have negative 3 times 6. We could have 3 times negative 6. And I think that's all. So we've got 6 different ways of getting 18 from multiplying two numbers, two whole numbers. So do any of these add to positive 3? Well, negative 1 plus 18, that's not going to work. 1 plus negative 18, that's not going to work. 2 plus negative 9, nope. Negative 2 plus 9, nope. Negative 3 plus 6, so if we start at negative 3, get 6 more in the positive direction. Okay, that one works. 3 minus 6, that's going to give us a negative 3. So there will only ever be one of these options that actually work. So we have negative 3 plus 6 and negative 3 times 6. I'm going to keep this color coded here. So just like the last two, we're going to put an x in front. Then we're going to put our first number here, so minus 3 and plus 6. And we are all set here. 2 left. Okay, let's take a look at the next one here. X squared minus 8x plus 12. So two numbers that add to negative 8 and multiply to 12. Okay, multiplying to a positive 12 but adding to a negative, that only happens if both numbers are negative. Okay, so let's see. How can we make 12 where both numbers are negative? Well, we could have negative 1 times negative 12. We could have negative 2 times negative 6. We could have negative 3 times negative 4. We could have, that's it. Do any of these add to negative 8? Not this one, not this one. This one does. Okay, so we have negative 2 plus negative 6 is negative 8. Negative 2 times negative 6 is a positive 12. We put our x's down, we plug our two numbers in, so minus 2, minus 6, and we've got this factored using our sum and product method. All right, last one. Now, I hope maybe you noticed, but here, in all 4 of these, there isn't a number in front of the x squared. Okay, so if we're using sum and product, it has to look like that. So right now, I can't really use sum and product, but common factoring, we always have to check for common factoring. Is there a number I can take out of all 3 of those? If there is, then maybe we can use that common factoring method and then try some sum and product afterwards. Now, looking at these 3, I think I can divide out of 2 and still be left with all whole numbers here. So if I divide out a 2, I have x squared plus 5x plus 4. Okay, that still looks good to me. Now, this is a trinomial, so something with 3 terms that we can factor. So let's see what we got here. Now, just like our previous examples, we gotta have 2 numbers that add to our middle number, which is 5, and 2 numbers that multiply to the last number, which is 4. All right, 4, you can have 1 times 4, you can have 4 times 1, you can have 2 times 2, and that's it. Now, do any of those 3 options add to 5? Well, we've got 1 plus 4 and 1 times 4. That satisfies both of those equations here. So our last step here, x plus 1, x plus 4, we've got ourselves another way to factor. Ask some questions. If you want me to take up some examples from our worksheets, let me know, and I'll try to get those out to you as soon as I can. This is all of our factoring methods, okay? So we have these 3. We're done for now. If you take the grade 11 course, I think there might be one more that you get into there. But this is all we're doing for this course. So these 3 methods. Common factoring, what can I take out of every term? Difference of squares has to have 2 terms that you can square root, and there has to be a minus in the middle. Sum and product, it has to be 3 terms, and they have to add to the middle term and multiply to the last term to be able to be factored. All right, until next time, bye.